Hey everybody, this is section 1.1, variables and expressions. Feel free for each of these lessons to pause the video right now during the do now, attempt it on your own, and then hit resume to check your accuracy. In the do now, they want you to figure out what is the mathematical operation shown in each equation, right? Addition, subtraction, multiplication, or division. Well, if you take a look at number 1, I see that dot there. Some students coming from middle school are unsure what that means. That dot means to multiply. Number 2, I see the minus sign, so that means subtraction. For number 3, I see division. And for number 4, we see addition. Okay, with each lesson, we're going to have some vocabulary terms. Feel free to pause while you're writing them so you don't fall behind, and resume the video when you're ready. A quantity is anything that can be measured or counted is a quantity. Anything that can be measured or counted. A variable is a symbol, usually a letter, that represents the value of an unknown. Symbol, usually a letter, that represents the value of an unknown. As you've worked through algebra and even into geometry and higher level maths, our most famous or most recognizable unknowns are the variables x and y. Of course, any letter or symbol could be a variable in mathematics. An algebraic expression is a mathematical phrase that includes one or more variables. So an example of an algebraic expression would be x plus 2. We have a variable and a number in one expression. A numerical expression is a mathematical phrase that involves numbers only. There are no variables. And notice how numerical looks a lot like the word number. So an example would be, instead of x plus 2, 5 plus 2. I don't see any letters involved in here, numbers only. It says use your vocabulary. It says circle the variables in each algebraic expression. Now I'm not going to circle, I'm going to highlight, but you guys feel free to circle on your own pages. 8 plus 4x. I see the letter x, that is our variable. Y plus 12, I see the letter y, that's our variable. 9z plus y, well this time we have two variables, z and y. In our last example, 8 divided by w plus 4 times w. Get those two w's. Those are our variables. So we're going to write an n next to numerical expressions, meaning numbers only. And write an a next to algebraic, which has variables. I see in the first example 6x, that's a variable, that's an algebraic expression. 5 divided by r, again another variable, algebraic. 11 plus 5, well that's numbers only, that's numerical. And 30 plus 14k, that's a variable, so it is algebraic. Number 1, writing expressions with addition and subtraction. The question they're asking us at the top is, what is an algebraic expression for 18 more than a number n? So we need to figure out what those mean. Complete the table with add or subtract. The phrase more than means to add. less a number means you're getting smaller, that is subtract. The sum of two numbers. That three-letter word sum means the result of addition. So think sum is 3 letters, add is 3 letters. Fewer than a number means to subtract. Circle the expression you could use to find 18 more than 6. So we started out with 6. If we have 18 more than that, we just said more than means to add. So 6 plus 18. So go ahead, circle 6 plus 18. Now write an algebraic expression for 18 more than a number n. Well, we said more than means addition, so put a plus sign in that box. Number 2, writing expressions with multiplication and division. What is an algebraic expression for the following word phrase? 6 times a number n. The phrase 8 less than a number tells you to blank 8. Well, again, that key word less than means to subtract. The product of a number x and 4. A lot of students tend to forget product and quotient. Product tells you to multiply x and 4. Phrase the quotient of 6 and a number tells you to divide 6 by x. The phrase n times 12, times is one that most students are pretty familiar with, tells us to multiply. The phrase the sum of n and 59 tells us to, remember, sum is a 3-letter word. It's the result of addition. So sum is 3 letters, add is 3 letters. Now write an algebraic expression for 6 times a number n. Remember, moving forward, we're going to try and use that dot for multiplication. 6 times n. Writing expressions with 2 operations. What is an algebraic expression for the following word phrase? 8 less than the product of a number x and 4. So write an algebraic expression for the product. Notice here we have 2 keywords in one phrase. We're going to break it down. Product of a number x and 4 means to multiply. When you multiply variables and a number, meaning a letter and a number, you write the number first. 4 times x. Or 4x. The phrase 8 less than a certain number tells you to subtract 8 from a number, or subtract a number from 8. 8 less than a number means I'm taking away 8 from that number. So it would be any number minus 8. So I am subtracting 8 from a number. Cross out the expressions that do not represent the word phrase 8 less than the product of a number x and 4. So we're going to combine these 2 ideas together now. We started out with 4x, and we are taking away 8 from that. So it becomes 4x minus 8. Using words for an expression, what word phrase can you use to represent each of the algebraic expressions below? Notice there's 4 of them, and there's 4 phrases. The first one, the blank of a number x and 8.1. Well, I see a plus sign here, and that 3-letter word for the result of addition was sum. Again, I see addition in number 2, but I also know when a number and a letter are together, that really means multiplication. So again, addition is the sum, so the sum of 10 times a number x. The next one, the quotient, meaning division of blank and 3. Well, your numerator is n, so you're dividing n by 3. And the last one, I see subtraction by 1, so that means 1 less than the product of 5 and x. Number 5, writing a rule to describe a pattern. Suppose you draw a segment from any one vertex of a regular polygon to the other vertices. A sample for a regular hexagon is shown to the right. Use the table to find a pattern, and what is a rule for the number of non-overlapping triangles formed. So we're trying to find some sort of pattern within this table on the right-hand side. Give the rules in words and as an algebraic expression. So they want us to find the number of non-overlapping triangles for a polygon with 4 sides. Now look at the table. If we have 4 sides, to find the number of triangles, we're going to do 4 minus 2. Well, 4 minus 2 is 2, so there's 2 triangles. And if you take a look, if we have a square, 4 sides, right? 1, 2, 3, 4. How many triangles did it make? 1, 2. A polygon with 5 sides would be 5 minus 2 if we look at the table. Well, 5 minus 2 is 3. If we take a look here, 1, 2, 3, 4, 5. And if I draw from one vertice to all the other ones, we get 1, 2, 3 triangles. The value of the expression in the table for a 6-sided figure is or is not the same as the number of triangles in the drawing of the hexagon. Well, a 6-sided figure, according to the table, would be 6 minus 2. Would be 4 triangles. If I look at my figure up top, it has 1, 2, 3, 4, 5, 6 sides, and it has 1, 2, 3, 4 triangles. So they are the same. So if we're to give a rule in words to find the number of non-overlapping triangles, we took in each one the number of sides, 4, 5, or 6, and what did we do to each of them? Subtracted by 2. So the rule is the number of sides minus 2. So our algebraic expression for n sides would be n minus 2. For the exit slips, what I would like you to do is pause the video, try them on your own, and then play the video to check for accuracy. Okay? So feel free to pause now and give it a go. This is a reasoning question. It asks you to use the table to decide whether 49n plus 0.75 or 49 plus 0.75n represents the total cost to rent a truck that you drove n miles. So you're moving, you need to rent a truck to move all your boxes from your old house to your new house. If you take a look at the cost, there are some things that stay the same in each of the rows. $49 plus 75 cents times. All of that stays the same. there's only one thing that changes, and it's this last number, 1, 2, and 3. And if you notice, the last number is identical to the number of miles. So what is the rule in words for the pattern shown in the table? It would be $49 plus 75 cents per mile. So our algebraic expression to represent the total cost of renting a truck is if we were to plug n into this expression. So it would become $49 plus 75 cents times n. So we'll put our answer below. 49 plus 75 times, try and use that multiplication dot, n. All right, you've completed lesson 1.1. Great job. Don't forget to submit your work to me either by taking pictures of your completed lesson and texting it to my Google Voice number, or scanning it and submitting it through email. If you have any questions, feel free to reach out via email, Google Voice. Have a nice one. Thank you.